Hello and welcome to today's lesson where we're going to look at the relationship between the ratios of the parts and when parallel lines are cutting through the sides of a triangle. Okay, so now when we look at these triangles, we've got two triangles here embedded into one another, and we're dealing with parallel lines. So if we know that this top line is parallel to this bottom line, okay, this goes back, to some of our first things that we worked with in geometry. Now the good part is we know that this top angle is congruent to itself. Now, since we have parallel lines and we have a transversal cutting through them, if we have parallel lines cut by a transversal, we now know that angles 1 and 2 are corresponding angles for those parallel lines. And based on that fact, I now have angle-angle congruence, or similarity, not congruence. Okay, so we have angle-angle similarity. So we know that these triangles are similar, and we are going to have proportional pieces that will allow us to solve for a missing value. So now, if we look down at this example here, okay, so using that previous example, let's develop a shortcut here, okay, and we're going to come up with a conjecture here in just a second. So now, if we know that we have proportional pieces, what we can do is we can look at how this side, and we know those lengths are not equal, how do they relate to this side over here? And I want to give them all different tick marks because we know the lengths aren't equal, but what we can work through and find is the fact that we've got the parallel lines cutting through. We now have proportional pieces. So y over 60, staying on that one side, bottom or left, over the right. And then we're going to move to the other side and set up the same proportion. And we want to make sure that left is on top, right is on bottom. Okay, it's really important just making sure that you're setting up your proportions properly, making sure that the corresponding pieces are in the same part of the fraction. So then we cross multiply. We've got 48y equals 60 times 36, 2160. Divide by 48, and we get y equals 45. Okay, so now, the conjecture that comes from this, if a line parallel to one side of a triangle passes through the other two sides, then it divides the other two sides proportionally. Conversely, if a line cuts two sides of the triangles proportionally, then it is parallel to the third side. Now, this allows us to be able to go through and solve some very specific situations. Okay, so we can set up and solve these. Since we know that we've got the parallel lines, we have the similar triangles, and we know that the sides are cut up proportionally. So if I want to do x over 12, okay, bottom over top on the right side has to equal the bottom over top on the right side. You just have to make sure that you're using those corresponding parts when you're setting up your ratios. And then when we cross multiply, we've got 8x equals 12 times 16, which is 192. Divide both sides by 8, and we get x equals 24. Okay, and always make sure that that answer makes sense based on what you're looking at. So we've got the 8 and 16. Okay, 8 smaller than 12. So we know that the 16 has to be smaller than x. And then we also know that x should be bigger than 12, based on looking at the opposite sides. So whenever you get an answer, make sure that you check your answer to see if you have the correct value. Now, these other two examples, very similar. X over 12, top over bottom on the right side. I have to make sure that I go top over bottom on the left side as well. So we've got 8x equals 12 times 24, 288. 288 divided by 8 gives us an x of 36. Okay, once again, looking at the shape, making sure that it makes sense. From 8 to 24, we can see it's a multiplier of 3. So from 12 to x, a multiplier of 3 gives us 36. Okay, so we have that correct value. Okay, same thing here. Triangle is just tipped a little bit differently. Remember, always identify where your parallel lines are, because you're working with the two sides that connect those parallel lines to each other. So if I want to go x over 20, I'm going from the left to the right on the bottom. So when I look at this top side, I have to make sure I go with the 45 first, left side over right side. And then we cross multiply and solve. So every one of the problems finishes the same way. You just have to make sure that you're setting up your proportions properly. So we've got 20 times 45 equals 900 divided by 25, and we get 36. Okay. Now, it doesn't matter how many parallel lines we have. We can have as many parallel lines as we want, and it still cuts it in proportional pieces. So all you have to do here when we're dealing with multiple parallel lines is just make sure that you're using your correct values. So if I'm going to go x over 42, and then I can go y over 42, okay, using the value that's given on the right side to help set up my proportions. Now we know the 42 is going to match with the 21 in both of these. And then what I need to do is make sure I'm pulling the correct piece to match with the x. The x matches with the 35. The y matches with the 28. Okay, y is the bottom level, so I have to use the bottom level on the left side. X is the middle level, so I have to use the middle level on the left side. And then from there, it's a cross multiply and solve again. 21x equals 42 times 35. Okay, 1470 divided by 21, and we're going to get x equals 70. Okay, multiplier of 2 from left to right, so that makes sense. Okay, we'll do the same thing on the bottom here. Okay, 21y equals 42 times 28. Okay, 1176. Divide by 21, and we should get 56. Okay, so the important part, once again, setting up your ratios properly, and then just being careful as you go through and cross multiply and solve. Okay, same situation here, so I'm not going to run through all of these, but what you want to know and understand is always start with the one piece that you know from each side. And what we know is on the top here, we know that the 14 and the 10 are in the corresponding pieces. So then when I'm using A goes with the 14, and then I need the corresponding piece from the bottom, which is 20. Okay, I want to show one other here just to give you a full example. Okay, 14 and 10. If we look at C, C is on the 10 side, so then I need to have the corresponding piece on the 14 side of the triangle to make sure that they're set up properly. Okay, and then from there we can cross multiply and solve. 10a equals 14 times 20, which is 280. And then we divide by 10, and a equals 28. Okay, numerically it makes sense. The 20 is bigger than the 10. The a has to be bigger than the 14. And we know that the 14 is bigger than the 10. Okay, so out of those four measurements, a has to be the biggest measure of them. Okay, and then finishing up for C, 14 times C equals 210. And then we have 210 divided by 14. Okay, gives us a measurement of 15. Okay, B sets up exactly the same way, so we'll save a little time and not go fully through that example. Okay, so now finishing up this conjecture here. Okay, what is this helping us prove? If two or more lines pass through two sides of a triangle are parallel to the third side, then they divide the two sides proportionally. Okay, one last piece for this lesson. Take a look at this triangle. This triangle is a little bit different than what we've seen before. So you have to be careful if you're given the lengths of the parallel sides. Okay, so notice we're given the lengths of the parallel lines. We're not given the measurements over here on the side. When this happens, this is not a part of the parallel line conjecture. What you have to do here is you have to go all the way back to your original rules of similarity, and you have to pull those triangles apart. Okay, and we'll show the difference between the right answer here and the wrong answer. Okay, so in this situation, I pulled the two triangles apart. My first triangle, ABE, has 4 for the left side, X for the bottom. And the large triangle, which we know is similar based on angle-angle similarity, ACD, I added the 4 and the 8 together to get a full length of 12 over 12. Okay, so this is the proper way to do it. Okay, we set up our ratios, 4 over x, left side over bottom equals left side over bottom. I cross multiply to solve. 48 equals x times 12, or 12x. Divide both sides by 12, and we get x equals 4. Okay, that makes sense measurement-wise. Okay, now, I'm going to set up the proportion the way it so oftenly is set up, because people just get used to saying, oh, 4 over x equals 8 over 12. Okay, so now I've set it up this way. I've got 8x equals 48, divided by 8, x equals 6. Okay, now, that number makes some sense. You know, it is a logical value here, but the problem was I wasn't dealing with proportional pieces. Okay, so when I'm talking about 4, 4 is the entire length of this side of the triangle. X is the bottom. Okay, now notice what happens when I go over to this side. 8 is not the full length. It is only part of the triangle. But when I have 12, I'm using all of the base. Okay, that's why that proportion does not work in this situation. Okay, you have to remember, okay, if you're given the bottom or the parallel lengths, You have to pull the triangles apart and set up your proportions from there. That is the end of our lesson, and have a good day.